Hello everyone, we're group 7. I'm Melissa.
I'm Jacopo.
I'm Judy.
I'm Madeline.
And I'm Maud.
Welcome to our project.
Hello everyone, today we're going to talk to you about the research we've been doing for the past 3 weeks. So as many of you guys know, plastic pollution is a huge problem and it not only affects humans but also nature. These plastics can take decades to degrade and even then they aren't completely gone, turning into microplastics or even nanoplastics.
And we'll be focusing on these microplastics, particularly those of the size of 80 to 180 micrometers, and how these affect the feeding behavior and general activity of the common brown shrimp.
To test this, we conducted a controlled lab experiment in Texel. We hypothesized that higher concentrations of microplastics would lead to reduced feeding activity and general movement in brown shrimp. We set up 18 tanks with aeration systems and divided them into 3 groups. Our control group with the assumed average concentration, our moderate group with 0.2 grams of microplastics, and our high concentration with 0.5 grams of microplastics. Each tank had 2 shrimps that we observed in intervals of 5 minutes per tank 2 times a day.
Later in the afternoon, we arrived at the shrimp fishing boat, and we finally got a shrimp. Once back in the lab, 2 shrimps were placed in each tank, and after letting them adjust for a little bit, we started observing in 5-minute intervals, writing down the duration of general and feeding movements.
The next morning we started good by starting observations on our alive and thriving shrimp. One even gave birth to tiny shrimps and other had molted to blend in with the tank. However, after observing, we noticed that the food pellets hadn't been eaten by the shrimp. So, as a solution, we started adding algae to the tanks to be sure of their survival.
The next day went pretty much the same by observing and feeding both in the morning and evening. However, after day 3, the results were different. There was a slight decrease in the feeding and moving activity in both the moderate and high concentration tanks. Unfortunately, later that day, the experiment needed to end, so we put our shrimp in ethanol to dissect them in the lab and cleaned up everything else.
Fast forward to the next week and we had a lot of lab work to do. We started out by dissecting the shrimp, taking out the digestive organs and placing them in a KOH solution overnight to break down the organic matter, leaving behind only the microplastics. After that, we placed these solutions in a 50 degrees Celsius oven overnight to further break down any organic material. The next day, we looked at the solutions under a microscope and looked for microplastics. We saw different amounts of microplastics in the different treatment groups. Now, with the evidence that the shrimp were in fact eating the microplastics and at different concentrations, we took the qualitative observations from Texel and created graphs with them in Excel.
From these graphs, we can make the conclusion that highly concentrated amounts of microplastics in a tank with brown shrimp will cause a negative trend in their feeding and movement behavior over time. Moderate amount of microplastics, though still very high, will not create as noticeable of a change in behavior over time, and the control tanks without added microplastics show that their behavior should have been trending positively after being placed in the tanks. When running this through an ANOVA, the low p-value on the day movement relationship proves statistically significant in the 2 groups.
We want to discuss the limitations in our research as well. Further investigation with a longer exposure time and a smaller sample size could potentially lead to better and stronger conclusions. We would also investigate the effects of different types of microplastics in order to recreate a more natural environment. However, our results definitely do suggest that even short-term exposure time to microplastics can begin to affect shrimp behavior. And since shrimps are essential detrivores and prey species, this could have broader implications for marine ecosystems.